Hi everyone, this is Mrs. GA, and today we're going to learn about the double angle and the half angle formulas. Okay, so let's start with our double angle formulas. So for sine, the double angle formula looks like this. It's sine of 2x equals 2 times the sine of x times the cosine of x. Now for cosine, the double angle formula is cosine squared x minus sine squared x. Now the two below it, they're not really different formulas. It's imagine you take that first formula and you rewrite different parts using your Pythagorean identities. So imagine again that first formula, but say we decide to rewrite sine squared as 1 minus cosine squared, which is one of our Pythagorean identities, and what we end up with is 2 cosine squared x minus 1, so it's just a rewrite of this first one. And by the same idea, if we substitute 1 minus sine squared for cosine squared, we end up with this third formula, which is 1 minus 2 times sine squared. So remember, this really is just a single formula, but it looks like there's three. We write it out or we expand it out just so you have these options and you could pick whichever one looks easiest for that problem. And then the double angle formula for tangent is 2 times tangent of x divided by 1 minus tangent squared of x. What I want to talk about where these formulas come from really quickly. These are actually formulas that you could really easily derive if you remember your sum and difference formulas. Because remember, sine of 2x is just sine of x plus x. So it's just a double angle formula. So remember, for the sine, it's sine, cosine, cosine, sine. So we do sine x, cosine, sine. And remember, the signs match for the sine formulas. So then if we combine like terms here, it's just 2 times the sine of x cosine of x. So again, if you ever forget this formula, just do the sum formula for x plus x. And then it's the same idea for the cosine and the tangent formulas. They really just come from the sum formulas that we learned previously. So again, these you could easily derive on your own as long as you know your sum and difference formulas. Okay, so let's try an example where we're going to be using these formulas. So here we're given that the cosine of x is negative 2 over 3 and x is in quadrant 2. They'd like us to find the cosine of 2x and the sine of 2x. So again, unless you had a calculator, you wouldn't be able to figure out what x was, and then you wouldn't be able to double it and find the sine and cosine. So these formulas are going to be really useful for problems like this. So let's start by just drawing a right triangle that represents this angle. It's in quadrant 2. So of course we're going to turn this into a right triangle. And if the cosine of our angle is negative 2 over 3, that means the adjacent side is negative 2. And this hypotenuse is 3. So we could really quickly do Pythagorean theorem and find that last side. Okay, so now that we have all three sides, we can look at the formula. So let's start with the double angle formula for cosine. Again, you can pick any of the three forms, but since we already know what the cosine of the angle is, let's use this form of it. Just so we don't have to find anything new yet. So cosine of 2x is going to be 2 times, well, we're going to take this and we're going to square it. And then we subtract 1. And now it's just a matter of simplifying. So here, remember, we're squaring the negative, so it's going to become positive. And then thinking of this as minus 9 over 9, this leaves us with negative 1 over 9. So that is our answer for cosine of 2x. Now for sine of 2x, we're going to use that formula, sine 2 times the sine of x times the cosine of x. So we know what the cosine of x is, but this is why we draw out the little picture right here. We can see from our picture that the sine of x is going to be root 5 over 3, just opposite over hypotenuse. So now we have the two values that we need for the formula. So we're going to substitute those really quick. And then here we're just going to simplify. and we get negative 4 root 5 over 9. And there you have it. Okay, so go ahead and pause the video and see if you can give this one a try on your own. We'll check the answers in just a few seconds. Okay, let's check right here. So again, I did set up the little triangle and I found this missing leg before I did anything else because I knew I would need it for the sine formula at least. So here I use that first form, or the third form of our formula, and I substitute negative 6 over 11 for cosine and simplified to get negative 49 over 121. Here's the double angle formula for sine. Remember, you need to use your little angle to find the sine of x. So sine is opposite over hypotenuse, so root 85 over 11. And then you just simplify to get negative 12 root 85 over 121. Okay, let's try another example together of when this formula might be useful. So here we're asked to verify this identity. Now when I'm looking at this identity, I know that I'm going to start with this side of my equation because it's really hard to take something that isn't a double or a triple angle and turn it into that. So we're definitely going to want to start with the left-hand side because we know we have a formula. So if you're thinking, well, we don't know a triple angle formula, we can try rewriting sine of 3x as the sine of 2x plus x. And then the denominator will stay the same. And then from here, we can expand this out using our sum formula. So remember, it's sine, cosine, cosine, sine. So sine of 2x, cosine of x, plus cosine of 2x, sine of x. And now here and here, I see that we can use our formulas from the double angle formula list. So sine of 2x is 2 sine of x, cosine of x. And then we're going to multiply it by cosine of x here. So I'll write this as cosine squared of x. And then for the other side, you can pick which formula you want to use. Let's try using 2 times cosine squared of x minus 1 times the sine of x here. And then all of this is over sine of x, cosine of x. So looking at the right-hand side, I do see that eventually I'm going to need to have 2 separate terms. So now could be a good time to split up this fraction into 2 separate fractions. So we have 2 times the sine of x times cosine squared of x over the sine of x times cosine of x plus 2 times the cosine squared of x minus 1 times the sine of x over sine of x, cosine of x. And again, we're always going to keep in mind what we're trying to turn this side into. So now we can simplify within our individual fractions. So here we have some common factors, and we're left with 2 times the cosine of x plus, and then here again we have a common factor of sine, so I can simplify that out, leaving me with 2 times the cosine squared of x minus 1 over cosine of x. And then here I'm looking at this, and I'm looking at what I'm trying to achieve, and I want to achieve 4 cosine x, and here I have 2 cosine x. So I know that I'm going to need to get another 2 from this. So I look at this and I say, maybe now's a good idea, or a good time to split this up into 2 more. So we can, again, split up that fraction. So it becomes 2 cosine squared of x over cosine of x minus 1 over cosine of x. And then you could see when you simplify this, it just becomes 2 cosine of x, which we can then add to the other one, giving us 4 cosine of x. So we've achieved this part. And then here we have minus, well, 1 over cosine is just secant. So here we have verified our identity. So remember, when you're verifying, it's really useful to always look at the other side of the equation, and that might kind of give you a hint of what you should do next. Okay, go ahead and pause the video and see if you can give this one a try. Start with the left-hand side and see if you can turn this into 1 plus tangent squared. We'll check our answers in just a few seconds. Okay, so here's at least one way you could verify this expression. Here I rewrote this using our double angle formula. When you combine like terms, you're left with this. Here, then we can simplify common factor. 1 over cosine squared is secant squared, and then this, going from here to here, is just our Pythagorean identity. So we have verified the identity. Okay, so now we're going to move on to the half-angle identities. So here we have the half-angle identity for sine, which is plus or minus square root of 1 minus cosine theta over 2. For cosine, the half-angle identity is plus or minus square root of 1 plus cosine of theta over 2. Notice both of the 2's in the denominator are within your square root. That's really important to note. And then for tangent, half-angle formula, there's 2 different variations that you might find useful. One is sine of theta over 1 plus cosine of theta, and the other variation is 1 minus cosine of theta over sine of theta. So you might be wondering why there's a plus or minus sign in front of your half-angle identities. So these are not in here to suggest that you're going to always have them. They're in here to remind you that depending on which quadrant we're in, sometimes our answer will be positive and sometimes our answer will be negative. So the plus or minus is going to depend on which quadrant theta over 2 is in. So here you actually have to be the one to decide, is my answer positive or is my answer negative? But again, they leave this in the formula because, of course, sometimes sine is positive, sometimes sine is negative, so you just need to be careful that you are adjusting your answer accordingly. Okay, so the half-angle formulas can be really useful to help us evaluate angles that you might notice are exactly half of angles from the unit circle. So again, this allows us to evaluate something like this without using a calculator. So when I see the sine of 22.5, I can rewrite that as the sine of 45 degrees over 2. Because again, 45 degrees is an angle that I can evaluate any trig function from because I know my unit circle. So now using the formula, we can rewrite this as the square root of 1 minus cosine of 45 degrees all over 2. So notice here, there's no plus or minus sign, and there's specifically no minus sign because we know that 22.5 is in quadrant 1, and sine is always positive in quadrant 1. So from here, all we need to do is simplify. Again, this is a value you should definitely have memorized. So we have 1 minus root 2 over 2 all over 2. And to simplify this, I'm going to multiply my numerator and denominator by 2, leaving me with the square root of 2 minus root 2 all over 4. And then I can simplify my denominator because square root of 4 is 2. So notice that my final answer, the square root is only in my numerator. So make sure it's really clear when you're writing your work whether or not your denominator is included within the radical or if it's not. Okay, go ahead and pause the video and see if you can find the exact value of cosine of pi over 8 without using a calculator. Okay, so if we rewrite this as the cosine of pi over 4 divided by 2, we can then use our half-angle formula to evaluate. Again, make sure you simplify fully and it's clear when your denominator is included in the radical and when it is not. Okay, here we have one more example to do together. So here we would like to find the tangent of u divided by 2 if we are told that the sine of u is 2 over 5 and u is in quadrant 2. Okay, so here let's start by drawing a little right triangle because we know u is in quadrant 2. I drew it here. And if the sine of u is 2 over 5, that implies that this is 2 and this is 5. So if you do a little bit of Pythagorean theorem, we get that this value is the square root of 21. However, since we are moving to the left, we do need to put a negative in front. Okay, so now we're ready to use one of our formulas. So remember, for tangent, there are two to pick from. So let's use this version. 1 minus the cosine of your angle divided by the sine of your angle. So for cosine of the angle, we can see that it is going to be negative root 21 over 5. So this will become plus, and then we'll do root 21 over 5. And then the sine of the angle was given, or we can use our triangle again. It should be 2 over 5. So I can see here that I can simplify my complex rational expression by multiplying the numerator and denominator by 5, leaving me with 5 plus root 25 over 2. And this is our final answer. Okay, go ahead and pause the video and give this last example a try. We'll check your answer in just a few seconds. Okay, so here we can see that I've drawn the angle. It says that u is in quadrant 3. So if the sine is negative 4 over 7, we can use Pythagorean theorem to find this missing leg, and it should be negative root 33. I used this form of the half-angle formula, and I substituted for cosine and sine, and then I simplified by multiplying the numerator and denominator by 7. Okay, that is all for today's video. Thank you so much for watching.